Hello everyone and welcome to this exciting session on the topic called as sets. One of the most fascinating topic and the most basic in the mathematics. My name is Divyansh Suryawanshi and I am from Indian Institute of Information Technology, Pune, Himachal Pradesh. And today we are going to simplify sets in a way that you will start seeing them everywhere in your daily life. Okay, so before starting this session, let me ask you one question. So what do your favorite snacks like chips, cookies, chocolates, fruits, anything else have in common? Let's consider one basket here. And this contains all your favorite snack food. Okay, let me consider this as your favorite chocolate. You have some snacks here. Let's consider the apple here, some fruits. So this is a basket. In mathematically, we can call it as a set. Okay, so they belong to a group, a collection that we call it as set. So set is not just a mathematical concept, they are present in our surrounding and help us organize data systematically. So let's get started. So let's start with the definition. What's definition is? A set is a well-defined collection of distinct objects. A set is a well-defined collection of distinct objects. What does this mean? Well-defined means that the objects in the collection should not be ambiguous. For example, the set of vowels in the English, that is A, E, I, O, U. Let me consider vowels as A, E, I, O, U. So here I am considering a set of vowels in English, A, E, I, O, U is a well-defined, but the set of good books, that's subjective, so it's not a proper set. For the good books, let's say I consider the Hindi fictional books, but my friend don't consider Hindi books are good. So it's not a proper set, so we cannot consider that. Okay. Also the objects in the set must be distinct. You can't have repetitions like 1, 2, 2, 3. Let's say an example as A set as 1, 2, 2, 3. So here there are the repetition of the elements. So this should not be done. The proper way of writing a set is 1, 2 and 3. This is a proper set. But if there is a repetition of the elements, this is not called a proper set. Okay, so example I have already given. What I have mentioned here, well defined. Well defined what means? No ambiguity. Okay, and what distinct elements is? Distinct objects means no repetition. Clear? Okay. So we can represent sets in two forms. What are they? Roster form and set builder form. Let me write it for you. First representation is roster form. What roster form is? We simplify, list out the elements of the set separated by commas and inside the curly braces. In the previous example you have seen that I have considered vowels as A, E, I, O, U. Okay. So what A, E, I, O, U is, these are the vowels, but they are different elements. and it is separated by commas, also in the curly braces. What it represents? It represents a set. So this is the roster form. The second form is set builder form. What set builder form is? We describe the set by giving a property that is element satisfy. For example, we can write the vowel example as, let's say A is the set A which represents the set of vowels. So X is 2, X is a vowel in English. So in set builder form, we can represent the same thing in this format. In the roster form, we can write it the same thing in this format. Okay. Now let's explore different types of sets with example. So there are some types of sets that we have. Let's discuss it one by one. So first is finite and infinite set. A set is finite if it has limited number of elements. For example, the set of planets in the solar system is finite. Okay, I am taking the example of finite set. Let's say in the solar system, we have the planets are, first start with Mercury, then Venus, then Earth, then Mars, then Jupiter, Saturn and Neptune. So this is a finite set because here we have only 8 planets. Here we have only 8 elements. So this is finite set. What infinite set represent? It has no end. Okay, infinite set means if it has no end. For example, the set of all natural numbers. Natural numbers, what it means? 1, 2, 3, 4 up to n. Or let's say infinite. Why infinite? Because it's an infinite set. I am considering the natural numbers from 1 to infinite that I cannot count. So that comes under the infinite set. Coming to the second type, that is empty set. What empty set is? An empty set has no elements. Let's consider an example. Think about trying to find out the loins in Antarctica. What's the answer? 0. So that's an empty set. Okay, and it is represented by 5. Otherwise, it is represented empty brackets. Okay, this is the same bracket that I have considered here, but there is no element in between. That means it is an empty set. Okay, and most importantly, it is also known as null set. It is also known as null set. Coming to the third part, what subset and superset are. Subset and superset. If every element of set A is also in set B, then A is a subset of B. I know it's a bit confusing. If every element of set A, let me take an example for that. A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5, 6. Okay. So if every element of set A is also in set B, then set A is a subset of set B. And conversely, B is a superset of A. How we can represent that? We can represent it as this. This is the symbol of subset. This represents subset. This is the symbol. And if it is the superset, then this would be the symbol. Okay. Coming to the fourth part, the fourth type is universal set. Universal set. The universal set contains everything we are considering in a given context. Okay, for example, if we are discussing the fruits, the universal set includes all the fruits. Okay, whether it is of apple, mango, banana, anything. Okay. Okay. If it is clear, then coming to the operations on the sets. Okay. We can perform several operations on the sets. Let's look at the main ones with example. So these were the type. Now coming to the operations of the sets. So the first operation is union, and it is represented as U. What union operation is? Union of two sets includes all elements from both the sets. Okay, the union of two sets includes all the elements from both the sets. For example, let's consider A as 1 and 2 and B as 2 and 3. 1 and 2 and B as 2 and 3. As you can see that I am representing this brackets and the commas. That means it's a proper set. Now I have to do A union B. That is the operation. Okay, the union of two sets includes all the elements from both the sets. That means the answer would be 1, 2 and 3. Not 1, 2, 2, 3. This is not, this is right. Why? Because I have already explained it is distinct objects. That means no repetitions. Okay. So here the answer would be 1, 2 and 3 without any repetitions. Coming to the second operation, that is intersection. What intersection is? The intersection of two slides include only the elements common to both using the same sets, and it is represented as this. This is exactly opposite of union. Considering the same example A and B, so what would be the A intersection B? Here we have 1 and 2, we have 2 and 3. So intersection means the common elements in both the sets. That is 2. So this represents intersection. The third part is difference. As the name suggests, what? Difference is A minus B. Okay, so the difference of A minus B includes the elements in A but not in B. Okay, considering the same example, here A has 1 and 2 and B has 2 and 3. So what would be A minus B is the elements of A only but not common in B. So what the elements are? It should be only 1. Okay. Coming to the fourth operation, that is complement. That is represented as the comma, the apostrophe that you are used to use in your English language. That apostrophe. Okay, the complement of A includes everything in a universal set that's not in A. Okay. Let's say the snacks you have, like the fruits, snacks and your favorite food items. That is a set A, but what universal is? All the food items in the world. That is the universal set, and the favorite food that you like is the set, which we can call it as A. Okay. Let me give you a brief detail how you can consider this in a proper diagram as well. Let's consider this as the circle. This circle represents A set and this circle represents B set. Okay. Set A element contains 1 and 2. let's say 1 and this is 2. Okay, and B represent 2 and 3. So 2 is already written, 3. Why I am writing 2 here? Because this is the common part of the circle, and what we have seen is that 2 is common in both the circles. If we need to find out the union of this, then 1, 2, 3 all are common. That means both the circles needs to be colored. Talking about the intersection was A intersection B, and the result was 2. So how we can represent it in the circle in the Venn diagram? This is called as the Venn diagram, and how we can represent it as this is A, this is B, 1, 3 and 2 is common. Answer is 2. The colored part would be 2. So this would be the answer. For the difference, this is set A, this is set B, but A minus B would be the elements of A only, but there should not be the common elements in both the sets. So the colored part would be only A. Please make sure that this is the only colored part, not the common part you need to fill out. Coming to the complement part, I am considering this rectangle as the universal part. Okay, this contains all the things. Suppose your snacks. So there are n number of snacks, and this is set A. That includes your favorite snacks. Okay, so this represents that. A represents your favorite snacks, and this universal set represents the whole snacks, every snack in the world. So this is how you can easily find out using the Venn diagrams. So the applications of set, let's consider. You have already been through all the mathematical terms, how to use, when to use. Now sets have amazing real life applications. For example, let's consider so that you can understand more better way. Okay, let's consider first situation, the search engine. Google uses intersections to find out more relevant result for your search query. That is the first example. Second would be the online shopping filters. When you filter by price, color or size, you are creating subsets. That would be the second example. And third example would be the social media. Okay, your mutual friends form the intersection of your followers and those you follow. Okay, these are the three examples. What I have considered is search engines. For the Google, this represents what? What kind of set? This is intersection. Understood? The second example would be social media, online shopping. How it is relatable? Because you are selecting the colors, everything. So here it is subsets. And third would be social media. Everyone is on Instagram and social media, every kind of platform. You can find on the display that the person you are going to search it out, you can find that there are mutual friends. What it represents? Also the union, because those you have followed and he or she has also followed. And also represent the intersection. So these are the basic three examples for your day-to-day life. Okay, so this is all about. Let me give you two questions to solve if you have understood this session. So first would be, let's consider this A set would be, let's say 1, 2 and 3, and let's say B is equal to 3, 4, 5. Okay, these are the two sets. You need to find out A union B and A intersection B. You need to find out A union B and A intersection B. The second question would be, if U has some set, let's say U is equal to A, B, C, D. This is the first set, and let's consider A is equal to A and C. Okay, so you need to find out A complement. This I have already discussed in the previous the few minutes before. So this is all about today's session. I hope you enjoyed learning about the sets. Keep practicing, as the concept is not just important for the exams but also for the understanding the world around you. This is all about the session. Thank you and have a wonderful day.